The union of spermatozoon and an oocyte in the process of fertilization produces a unique individual called a zygote. Now, the zygote is the simplest form of this new individual and will begin to split and divide into new cells that will become organized, specialized, and form shapes and new structures as it becomes more complex. Around 24 hours after fertilization, the zygote begins to increase its number of cells by rapid mitosis, but without increasing its size. The cells become smaller as their number doubles with each cell division, and so we call this process cleavage. The cells of the zygote are called blastomeres. They become compacted and tightly squashed together while still enclosed within the zona pellucida. From around the 12-cell stage, the ball of cells are called the morula. The cells of the morula will not only give rise to the cells of the embryo, but also to many of its supporting structures, such as the placenta. By this stage, the cells are communicating with each other and becoming organized and ready for the next stage. The blastomeres in the middle of the morula will become the inner cell mass, which is also known as the embryoblast. These cells will directly form the embryo. The blastomeres on the outside of the morula will become the outer cell mass, also known as the trophoblast. They will form the supporting structures for the embryo. Now, the morula passes into the uterus around 4 days after fertilization. Trophoblast cells pull luminal fluid from the uterine cavity into the center of the morula. So the fluid-filled space that forms in the center of the morula is called the blastocyst cavity. The cells of the inner cell mass are then pushed to one end of the cavity, and so we call them the embryonic pole. With these changes, the morula is now called the blastocyst. Around 5 days after fertilization, the blastocyst loses the zona pellucida. By doing this, it becomes able to grow in size and interact with the uterine wall. The blastocyst then attaches to the endometrial epithelium that lines the uterus. This triggers changes to the trophoblast and to the endometrium in preparation for the implantation of the blastocyst into the uterine wall. Now let's move on to twinning. So twinning can occur in different ways. So two separate blastocysts may form when different sperm fertilize two different ova released from the ovary simultaneously. This leads to the formation of bichorionic diamniotic twins, meaning that the twins will have separate placentas and separate amniotic sacs respectively. They may even be of different sexes. So we call this type of twins dizygotic twins, which is commonly known as fraternal or non-identical twins. Now, another way of forming twins is by splitting of the zygote. So a zygote may split during cleavage or later when the inner cell mass has been formed, or even later when the embryo has become more complicated and formed a bilaminar embryonic disc. If the zygote splits during cleavage, each blastocyst will implant separately. However, if the zygote splits at a later stage, the two embryos may share the same chorion, amnion, or placenta. So the splitting of a single zygote would produce identical twins. These twins would come from the same ovum and same spermatozoon. So these would become monozygotic twins, commonly known as identical twins. This is much rarer than the fraternal twins. It is common for monozygotic twins to share a placenta or be monochorionic, but have separate amniotic sacs or be diamniotic. Now, this situation arises from cleavage of the blastocyst 4 to 8 days after fertilization. A small number of monozygotic twins share their amnion. This is called monoamniotic twins. It usually occurs if the division of the zygote occurs later than 9 days after fertilization. So the more tissue shared between twins, the greater the risk to the embryos. Hence, dizygotic twins have the lowest mortality risk. Now, when the zygote splits incompletely later than 12 days after fertilization, then this would form conjoined twins, and conjoined twins are at a much higher risk. Twins are more likely to be born prematurely, which results in low birth weights and other associated complications. In vitro fertilization or IVF treatments can result in multiple zygotes because of the drugs used to encourage ovulation. Clomid is a drug that blocks estrogen receptors, so the body perceives low estrogen levels, and consequently, follicle-stimulating hormones or FSH is released and more follicles mature in the ovary to be released and fertilized. Thanks for watching. Remember to press the like button and subscribe to the channel. More videos coming up. See you in the next one.